Okay, so if you missed the lesson today, I'd like you to take a minute or a few minutes, pause, and do the warm-up. It doesn't take terribly long. I want you to write the converse, inverse, and contrapositive of this conditional statement. Then we want to know if each one is true. Is this one true? And then is the converse, inverse, and contrapositive, is that true or false? And then just answer these two simple questions right here. So pause the video and give it a try. If you really don't remember it, then you can just watch me do it. But it's good for you to try to practice it if you seem to remember what to do. Okay, so the conditional is, if you don't have water, then you die. So the converse of that is when you flip the second part with the first part and the first part with the second part, the hypothesis, conclusion. Switch them. So the converse would be, if you die, then you don't have water. Okay, we just flipped them. Now the inverse, we don't flip the two. We take this statement and we negate it. And then we take this statement and we negate it. So we give the opposite truth value. So if you don't have water, we're going to say if you do have water. That's the opposite. If you don't have water, the opposite is if you do have water. Opposite meaning, I should say. It's the opposite meaning. So if you don't have water, we're going to say if you do have water. Okay, that's the opposite meaning. And then you die. Well, the opposite would be then you don't die. Okay, now the contrapositive, if you remember, is when you flip the hypothesis and the conclusion. You flip these two statements and you negate them. So we're going to put this first, then you die. We're going to say if you don't die, because not only are we putting this first, we have to negate it. So we negate it, then you don't have water. The negation of that is then you do have water. Then you do have water. Okay, so now let's look at the truth. This is the conditional, original conditional right here. If you don't have water, then you die. Okay, is that true, that if you don't have water, you die? That's true. You will die if you don't have water. I don't know, 3 or 4 days, 5 days, I don't really know the limit. You could Google it. But if you don't have water, you will die. Okay, if you die, then you don't have water. If it's false, that means that we can come up with a counter example. So if you die, then you don't have water. Well, you could die, okay, but that doesn't mean that you don't have water. You could die from many other things. You could fall out of a hot air balloon. You could have a heart attack. You could get hit by a bus. So if you die, then you don't have water. We cannot conclude this because this is false, because you could die from something else. We cannot conclude this, that you don't have water. It could be for some other reason. Other reason. Alright, so if you do have water, then you don't die. The inverse. Is that true? If you have water, then you don't die. Is that true? Like, I'll live forever if I have water? No, we cannot conclude that if I have water, then I don't die. That's false, because I, again, could die from some other reason. So if I do have water, I cannot conclude that I don't die, because, like I said before, a hot air balloon, falling out of a train, I don't know, stroke. Okay, so contrapositive. If you don't die, then you do have water. So if you don't die, okay, so if you don't die, I live, then I must have some water, right? Because if I didn't die, then I had to have some water. Because if I don't have water, I'm going to die. So if I don't die, then I must have some water. This is true. And remember, the conditional and its contrapositive always have the same truth value. So if this was true, then the contrapositive is also true. Okay, that was a quick review on converse, inverse, and contrapositive and truth values. Remember, if you're going to prove something false, you have to come up with a counterexample for what could happen. All right, if angles are supplementary, they add up to 180 degrees. Right? And if two angles are complementary, they add up to 90 degrees. Right? That's the definition of supplementary. And that's the definition of complementary. Okay, so the last test we took was on Chapter 3, 0.1 to 3.4. We're still in Chapter 3. This is Chapter 3. This is 3.5. But let's review. We're going to consider that we have two lines that are coplanar and they're cut by a transversal. And we know that if these lines are parallel, which we're told in this case that L and M are parallel, if lines are parallel, then corresponding angles are congruent, right? Those two angles will be congruent. Parallel, then alternate interior angles are congruent. So this one and this one are alternate interior, right? We know that, and so is this pair. If lines are parallel, then alternate exterior angles are congruent. So alternate exterior angles, this one and this one, right? They're exterior and they're alternate. If lines are parallel, then same side interior angles are supplementary. So that means that the same side, this angle right here and this angle right here are the same side, they're interior, right? And so they are supplementary. They add to 180. And so are these. These two are also going to add up to 180. And then the same side exterior angles are this one right here. Here's one and here's one, right? They're the same side exterior. I'm going to put a little dot in the middle to make it different than the other one. And these are also another pair of same side exterior angles. Okay, this pair and this pair. Remember that? Okay, that's all review. In fact, you just took a test on it. Well, we're going to state the converse here, and we're going to prove lines are parallel by being given the conclusion. So, for example, let's take A. If lines are parallel, then corresponding angles are congruent. We're going to say if corresponding angles are congruent, then lines are parallel. So we're doing the opposite, okay? Instead of the converse. If lines are parallel, then corresponding angles are congruent. Well, if corresponding angles are congruent, then lines are parallel. And that's going to be a true statement. That's called the converse theorems. And they're also true. So the conditional is true. This original theorem, these are all true. And so is the converse. So for letter B, instead of saying it in this way, we're going to flip it. If alternate interior angles are congruent, then lines are parallel. And let's draw a couple of examples of this. So let's draw two lines cut by a transversal. Let's just give an example. If this angle and this angle, those are corresponding, if those are congruent, then these lines are parallel. And we can draw this picture as well. I know I'm going a little fast because I'm trying to record this the night before class, but you can slow it down on YouTube. You can slow down the speed or pause to. But now let's draw the alternate interior angles. So if we have two lines cut by a transversal, these pictures kind of small, and here's an alternate interior angle with this one, right? These are alternate interior angles. If those are congruent, see how I marked them congruent? Then those two lines are parallel. Okay. So if the alternate interior angles are congruent, we just proved that these lines are parallel. Let's write the converse of letter C. If lines are parallel, then alternate exterior angles are congruent. So if alternate exterior angles are congruent, then lines are parallel. And let's draw a picture. Alternate exterior angles. So I'm going to give an example. Here's one, and then here's one, right? They're alternate sides of the transversal. And they are Alternate sides of the transversal and exterior to the two lines. Well, if those are congruent, then these lines are parallel. Okay, so I'm going to say if this is true, then the lines are parallel. Okay, letter D. If lines are parallel, then same side consecutive interior angles are supplementary. So if same side angles are supplementary, then lines are parallel. You get the picture? We're writing the converse. And these theorems and postulates here, if we write the converse, these are also true. So same side angles are supplementary. Then I'm going to go ahead and draw a picture with same side interior angles. Oops, I forgot to write interior. Same side interior. So same side interior angles are supplementary, those two. If those are supplementary, so let's label this 1 and 2. If the measure of angle 1 plus the measure of angle 2 equals 180, right, then lines are parallel. And the last one, we're going to reverse this one as well. If same side or consecutive exterior angles are supplementary, then lines are parallel. Okay, so let's draw that picture. Same side consecutive exterior. So this one and this one, same side, oops. Same side exterior angles. I think I forgot to move it up. I'm sorry. Okay, so if that's true, these are supplementary. Okay, angle 1 and angle 2 here, the measure of angle 1 plus the measure of angle 2 equals 180. Then these lines are parallel. Okay. Okay, now we're going to do the back side. We can use the converses then. Actually, I'll just keep this right here. We can use these converses to see if these lines are going to be considered parallel. So, and this is a bad printing. Yours will be better, but this is 63 and 63. Okay, so are these two lines parallel? We're going to determine if these lines are parallel. If they are, we're going to state the converse. So this angle is 63 and this angle is 63. So that means that these two angles are congruent. Well, if these two angles are congruent, those are alternate exterior angles, right? So if alternate exterior angles are congruent, then lines are parallel. That's the converse of the statement. If lines are parallel, then alternate exterior angles are congruent. So we're going to say if alternate exterior angles are congruent, then lines are parallel. So we can say yes, these two lines are parallel because these are alternate exterior angles and they are congruent. Okay, now this one is, I can't read it very well. I think it's 106. You'll have it on your paper a little clearer. Okay, so these two angles, are these lines parallel? Can these two angles determine if these lines are parallel? Okay, these two angles are vertical angles. And you'll notice that we don't have anything up here on this line to correspond with any of these angles down here. So this is going to not prove. We cannot determine if these lines are parallel. So we don't know. Not sure. Because vertical angles are congruent, it's not one of our converses, right? And you'll just have to look at your notes to be sure about that. Now this one says 125 and this one says 65. Okay. can we determine, are these two lines parallel? This is L and this is M. Are these two lines parallel? Well, these are consecutive interior angles, right? Same side interior angles. So if these are supplementary, then these lines will be parallel. Well, let's see if they add up to 180. 125 plus 100 plus 65. Well, using your calculator or your brain, we get 190. So these two angles add up to 190. So if these add up to 190, that means that they're not supplementary, so these two lines are not parallel. So the answer to this is no. Okay, we can't say these lines are parallel. In fact, they're not, because these two need to add up to 180 and they don't. Okay, let's look at this next one. This angle is congruent to this one. Well, what kind of angles are those? Those are corresponding angles. And we're being told here that they are congruent. So if these corresponding angles are congruent, then yes, these lines are parallel. And the converse is, if corresponding angles are congruent, then lines are parallel. This is going to be looking at your notes to help you with this. I think will be good, unless you can remember them. Okay, let's look at these two angles here. We have an angle here and we have an angle here. Here's our two lines. They're cut by the transversal. So what kind of angles are these? What relationship do they have? They're alternate sides of the transversal, interior of the two lines. So these are alternate interior angles. Alternate interior angles. And they're congruent. Well, if these are congruent, then yes, these two lines are parallel. So if alternate interior angles are congruent, then lines are parallel. In the last example here we're going to do is, this is 48 and this is 132. Okay, so in order for these lines to be parallel, these two same side exterior angles would need to be supplementary. In order for these lines to be parallel, these two need to be supplementary. Well, let's add them up and see if they add up to 180. So 48 plus 132, that equals 180. So since these two angles are the same side and they're supplementary, then the lines are parallel. So if same side exterior angles are supplementary, then lines are parallel. All right, so if I told you that, and go ahead and pause it so you can catch up, but if I told you that angle 1, for instance, was supplementary to angle 4, so this angle right here is supplementary to angle 4, would lines C and D be parallel? Same side exterior angles. If same side exterior angles are supplementary, then yes, line C is parallel to line D. Okay, let's look at angle 2 and angle, that's a 7 right there, and angle 7. I'm going to tell you that those two are congruent. Angle 2 is congruent to angle 7. So if angle 2 is congruent to angle 7, well, are these alternate interior angles? Yes, these are alternate interior angles, and they are congruent. So if these two angles are congruent, then these lines are parallel. C again is parallel to D. Okay, let's try another one. Let's say angle 4 is congruent to angle 12. Okay, so this angle right here, 4, is congruent to angle 12. Okay, if these two angles are congruent, can we say that line A and B are parallel? Well, these are corresponding angles. If corresponding angles are congruent, then the lines are parallel. So yes, A is parallel to B. Now what if I said angle 4 is supplementary to angle 8? 4 is supplementary to angle 8. Well, that's true because those are a linear pair. But does that show us that line A and B are parallel, or that line C and D are parallel? No. This is just telling us that this linear pair is supplementary. And we already knew that. All linear pairs are supplementary. So this does not show any, not sure what would be parallel there, right? Not sure. Okay, let's say the angle 9 is supplementary to angle 12. So this time we're looking at angle 9 and 12. This one, let me get a different color. This one and this one. Well, if they're supplementary, that means that same side exterior angles are supplementary, and that means that line C is parallel to line D. Because if these lines are parallel, then these two angles will be supplementary. And conversely, if these two angles are supplementary, then these two lines are parallel. Let's say angle 10 is supplementary to angle 11. So these two angles right here, this one and this one, can you tell that that's orange? Okay, so 10 and 11. Well, if these two angles are supplementary, then yes, we can say that these two lines are parallel to each other, because these are same side interior angles. They're supplementary, so that means that line C is parallel to line D. Because we know that if lines are parallel, consecutive interior angles are supplementary, so the converse is true. If these two angles are supplementary, then these lines are parallel. Okay, so that's going to be your practice today, but let's just look at a few more ways that you could use this to prove lines are parallel. Using algebra, what value of x makes these lines parallel? So in order for L and M to be parallel, we look at these two angles that were given, 53 and 8x minus 9. Okay, so what kind of angles are these? These are consecutive or same side, right? These are same side interior angles. So this angle and this angle are same side interior angles. Now, if they are supplementary, then these lines are parallel, right? Because if lines are parallel, these two would be supplementary. Well, the converse is true. If these two are supplementary, then these two lines are parallel. So I'm going to add these up and solve for x to see what value would make these supplementary. So 8x minus 9 plus 53 equals 180. What value for x is going to make those supplementary? Well, let's solve for x. 8x, and this is plus 44. Bringing those together equals 180. Now I subtract 44 from both sides, and we get 136. And then we divide both sides by 8, and we get 8 equals 17. So in order for these two lines to be parallel, these two need to be supplementary. So x would have to be 17. Okay, pause it and write that down, rewind it, watch it again. Let's look at this one now. This is 26x minus 4, and this is 15x plus 29. Okay, so here, what value for x would make these lines parallel? Well, these two angles here are alternate exterior, right? They're alternate exterior angles. So if lines are parallel, alternate exterior angles are congruent. Well, the converse says if these are congruent, then these lines will be parallel. So we need to make these lines be congruent, these angles be congruent. We need to find the value for x that makes these angles congruent. So 26x minus 4 equal to 15x plus 29. So if these two angles are congruent, then that means the alternate exterior angles are congruent and these lines are parallel. All right, so let's solve this equation. We're going to subtract 15x from both sides. And we get 11x minus 4 equals 29. We're going to add 4 to both sides. We get 11x equals 33. Divide both sides by 11 and we get x equals 3. So if x equals 3, then these two angles will be congruent. All right. There's just two other ways to prove that angles are congruent. Let's draw a line. And this theorem right here, F and G, there's two other ways. So there's 7 ways to make lines be parallel, okay? If two lines are parallel to the same line, then they are parallel to each other. All right, so here's a line. Now here's a line that's parallel to it, okay? So this line and this line are parallel to each other. Well, that's if we draw another line that's also parallel to this line right here. So let's call this one A, let's call this one B, and let's call this one C. So A is parallel to B. If C is also parallel to B, then A is parallel to C. A is parallel to B, B is parallel to C, A is parallel to C. So we can say A is parallel to C. Or we could draw the picture A is parallel to C. Okay? If A is parallel to B and C is parallel to B, they're both parallel to B. This is like the transitivity property. You can use the transitive property with parallel lines. So if A is parallel to B and B is parallel to C, then we can say, if A is parallel to B and B is parallel to B, we can say A is parallel to C. Okay? We've talked about that before. Now this one I don't know if we've talked about. If two coplanar lines are perpendicular to the same line, then they are parallel to each other. You sort of did a proof at one point to prove this, but we never really talked about it. So two coplanar lines. So here's a line, and here is a line that is perpendicular to it. Okay? Let's call this one A, let's call this one B. Okay, so B is perpendicular to A. Well, if we have another line that is also perpendicular to A, let's call it C. If C is also perpendicular to A, so B is perpendicular to A and C is perpendicular, it will be true that B is parallel to C. So these two lines will be parallel. Okay? If B is perpendicular to A and C is perpendicular to A, then believe it or not, B and C are going to be parallel to each other. And they look parallel, don't they? Well, it's true. We're not going to. It is true. And so we can prove that lines are parallel to each other if they're parallel to the same line. Or we can use this. We can prove lines are parallel that way by transitive property. We can also prove that lines are parallel if they are perpendicular to the same line. So this line and this line are perpendicular to this line, so they are parallel to each other. So that is 7 ways to show that lines are parallel to each other. The converses of the theorems that we practiced all through chapter 3, these converses, will prove that lines are parallel, all 5 of those. And then also the transitive property with parallel lines and 2 lines perpendicular to the same line. Okay, so there are 7 ways. You will write them again in your homework to try to get them into your brain and to fully understand the original theorems and postulate and the converses are true when you're dealing with these parallel lines. Okay, I'll see you soon.